Hello students, first chapter real numbers. In that chapter already we discussed Euclid division lemma. Hope you all remember that. Given positive integers a and b, there exist unique integers q and r. It must satisfy the condition a equal to bq plus r. The remainder must be greater than 0 and less than b. Okay, this is the Euclid division lemma. By using this, we have to find out the HCF. This one already I taught you 455 and 42. One example I given this. In this one small corrections. When you got the remainder 0, that time what is the quotient? That is not the answer. What is the divisor? That is the answer. Okay, here 7 is the divisor, no? So that is the answer. Okay, now Euclid division algorithm. Euclid division algorithm. Okay, by using that Euclid division lemma, we have to derive this. The same thing to find HCF of two positive integers, say c and d, with c greater than d, follow the steps below. Nothing is there. Now we have to find out HCF of any two positive integers. Okay, c and d, that positive integers c and d, with c greater than d. Don't get confusion about that c and d. They are given two integers, right? Among the two integers, which is the greatest number, that we consider as c, and which is the smallest one, that one we consider as d. Okay, and it must satisfy the three conditions. First one, apply Euclid division lemma. Apply Euclid division lemma. For that I written here the short form EDL. EDL means Euclid division lemma. To C and D. C and D means the given positive integers, no, that one C and D. We find the whole number Q and R such that C equal to DQ plus R. It must satisfy the Euclid division lemma. That condition, C equal to DQ plus R. Okay, that is the first condition. Next, the second one, if R equal to 0. Here R means, you know that, right? R means remainder. D is the HCF of C and D. Once you got the remainder 0, that time what is the divisor is there? That is the HCF of the given integers. Okay, suppose if you didn't get the 0, if you didn't get a remainder as 0 means, again we have to apply the same Euclid division lemma. Okay, continue the process till the remainder is 0. Once you got the 0, at that time, what is the divisor? That is the HCF of the given integers. Okay, yes. Now, let's see that exercise 1.1, first sum. Use Euclid division algorithm to find the HCF of first one 135 and 225. Now, we have to find HCF of these two numbers. Okay, by using Euclid division algorithm. Euclid division algorithm means nothing is there. We have to find out HCF of two positive integer. It must satisfy the three conditions. First one, Euclid division lemma, C equal to DQ plus R. And second one, if R equal to 0 means divisor. That divisor is the HCF. Suppose if we didn't get the remainder 0 means we have to continue the process till we get the remainder 0. Okay, once we got the remainder 0, at that time what is the divisor? That is the HCF. Okay, this is the Euclid division algorithm. Okay, by using this one, we will solve this one. First one, 135 and 225. Now we will find HCF of these two numbers. As I told, C is the greatest number and D is the smallest number. Here the greatest number is 225. So we consider as 225 as a dividend and 135 as a divisor. Okay, one time 135, one time will come. If you put the 2 times means it more than 135, no? So one time only 135, remainder 90. Remainder 90. So first I written here the 225 divisor into quotient plus remainder, which means yes, Euclid division lemma. Okay, that one. I didn't get the remainder 0, no? So again we have to do the same thing. Now we consider 90 as a divisor and 135 as a dividend. Again, one time only we will get remainder 45. Okay. So now we will write that 135. How we have to return? Divisor into quotient plus remainder. 90 into 1 plus 45. But still we didn't get the 0, no? Remainder not equal to 0 only is there. So again we have to do 40. Now we consider that 45 as a divisor and 90. That 90 is a dividend. You know that, right? 2 times 90. Now we will get the remainder 0. We got the remainder 0, right? At this time, what is the divisor? What is the divisor? This 45 is the divisor, right? So this is the HCF. Before that you write for 90. For 90, divisor into quotient plus remainder. Okay, you got the remainder 0, correct? So at this stage, what is the divisor? 45. So that 45 is the HCF of 135 and 225. Therefore, HCF of 135 and 225 is, what is the answer? Yes, 45. Hope you all understand, right? Now we will move to the second one. Second sum, the same. We have to find out HCF of 196 and 38,220. Okay. Here, which is the greatest number? Obviously, 38,220 is the greatest number. 196 is the smallest number, right? So, we consider the 38,220 as a dividend. 196 as a divisor. Okay. You just try yourself at 195 times the same 38,220 will come. Okay, so remainder 0. Okay, within a one step I did this one, right? So 38,220. How we have to write? Divisor into quotient plus remainder. Divisor into quotient plus remainder. Okay, so 196 and 195 plus 0. I got the remainder 0, right? So in this stage, what is the divisor here? 196. So that is the HCF. Therefore, HCF of 196 and 30,220 is 196. This is the HCF. Okay. Next, third subdivision. 867 and 255. Among these two numbers, obviously 867 is the greatest number, right? 867 we consider as a dividend and 255 as a divisor. Okay, how many times it will come? 3 times. Okay, 3 times 765. You just do it yourself. Okay, remainder. What is the remainder? 102. You just written for 867 divisor into quotient plus remainder. We didn't get the remainder 0, right? So again we have to do. Now we consider 102 as a divisor and 255 as a dividend. How many times it will come? Yes, 2 times. 2 times 204. So remainder 51. Again we have to do. First we have to write this for 255. Divisor into quotient plus remainder. We didn't get the 0, no remainder. So again we have to do. Now we consider 51 as a divisor and 102 as a dividend. How many times? 2 times 102 will come. So remainder 0. You got the remainder 0, right? In this stage, what is the divisor? Here, this is the divisor, right? What is this? 51. So that is the HCF of the given numbers. Now we have to return for 102 divisor into quotient plus remainder 0. We got the remainder 0, right? So in this stage 51 as a divisor. So therefore the HCF of 867 and 255 is 51. Okay, that's it. Hope you all understand about that division algorithm. Yes, exercise 1.1 first sum, 3 subdivisions. Hope you all understand. Thank you, students.